So good evening, sir.
Yeah, good evening.
So today we are going to present our final year project, that is automated detection and classification of malaria parasite using convolutional neural network. We have our group is comprised of three members: myself, Avi Banerjee, my friend Amarjit Borua, and my other friend Milon Jyoti Bora. And we have been guided by Dr. Divyajyoti Bora, sir. So let us see a glimpse of what is our project and why it is required. As we know, malaria is a life-threatening disease and it demands early diagnosis, but the traditional technique takes a lot of time. So we want to make such a system which will take less time and will help the patient with lower cost and lower available system configuration to do it, to do the processing and diagnose the disease faster. So what is our problem statement? So our problem statement is to develop an automated system using the CNN for accurate and efficient detection of malaria parasite in blood samples to reduce the reliance on human expertise. As we know, human expertise can cause many errors which can be a life-threatening thing for the patients. So next, so first, we have to go for the data sets, because if we want to make a model, it is very important that what type of what data set we are taking, because the main thing in a machine learning model is the data. So the data set we have taken from Kaggle, but it is also present in the National Library of Medicine. But for the greater access of the people, they have shifted it to the Kaggle, because many people don't know about the National Library of Medicine, but the Kaggle is a well-known platform from where people can get the data sets. So our data set is comprises of 27,558 images, from where the infected images are 13,779, and similarly the infected. Both are equally 50% divided. So these are some images of samples of the uninfected data, and these are some samples of the infected data. So next, model. So what are the models that we have taken into consideration? So first we have tried with 5 models. That is the basic baseline CNN, then inception with VGG net, then CNN with dropout layer and ResNet. After doing these 5 models, we have done a comparative analysis. So the comparative analysis goes like this: we have taken many parameters into consideration, like the training, accuracy, validation, testing, epochs, total time. So from that we have got that the main 2 models that are giving the best accuracy and taking less time as compared to the other models are the Inception V3 and ResNet 50. So we have taken these 2 models as our the best 2 models, and what we have done will be explained by our friend Milon next.
Thank you, Abhi, and good evening, sir. Now
Good
I'm going to
continue.
discuss. Okay. Now I'm going to discuss about our ensemble part of the project. So first is what is ensemble learning. So it is a very powerful technique which help us to combine the multiple machine learning model in a single one, which help us to get the better accuracy as well as the better generalization. And to using this ensemble learning, our main goal is to reduce the biasness of the dataset, then reduce the variances, and improve the capability of the single model with the help of integrating both or the multiple models, different parameters or like some other features. And after that, we have done the model combined for ensemble. Here we are taken from 2 models or from the comparative analysis. These are the testnet 50, which helps to good for the residual learning. Residual learning, sir, is a process which helps us to learning the deeper features of the dataset. And second one is inception wiki. This is help us to get the multi-scale feature extraction. So next is result receipt. After doing the ensemble, we got the training accuracy around 96.21%, then validation accuracy 97%, and testing accuracy 97%. These are the graph after the ensemble technique. First one is training and validation accuracy. Then second one is training and validation loss accuracy. And next is the next part will be explained by my friend Amonsi. Thank you.
Thank you, Milan. So now we have come to the part that is verification. We have come to cross verification. So first, what is cross verification? Now, cross verification is a process by which we can check or validate the results that we have achieved from our models. For example, accuracy. If we only see the accuracy that is generated through the model at one time, suppose train or test accuracy, we may never know that uh, what type of other things that the model faces. Suppose accuracy in cross verification, if shown is 95, that means that uh, the probable accuracy that we may get from the model is around 87 to 98. So like that, we can actually you can say pinpoint to what extent we can get expect our accuracy for. And it's not just about accuracy because we have uh, other components also. So and also next, why cross verification is important because it ensures accuracy and it increases reliability. As I said that the model will give you a accuracy, but how will you know that this accuracy will be you will be getting for multiple occasions at a time? And by doing cross verification, you will be knowing the ranges, the minimum range and the maximum range. So it will increase the reliability of for it. It also reduces an errors and biases because accuracy, precision, sensitivity, recall, all other things, these you can say matrices are also can be generated through cross verification. So looking at it, you will be knowing that if it has more biases, if it goes has more errors like that. It enhances credibility because through cross verification results, you can say that we will be always getting these results. It increases credibility like that, and also it validates the critical system. That means if we are getting a perfect result, or you can say a good result in cross verification, that means our system is working fine. Moving onwards, how a cross verification works. Here is an example of five-fold cross verification. First, it will shuffle the data. Then for one model, it will take, you can say it's n is equal to 12 and k is equal to 3. So it will always take three houses, you can say for test and others for the train. Like that, it will generate three poses. And by that, we will be getting the mean results. And we are only want what is the mean result. Moving forward, here are the metrics that we have used. We have accuracy that gives the accuracy everyone knows. Now recall. Recall is an important factor because it shows the positive, true positive and true negative. How the system discovers it, true positive and true negative. Precision means that how much precision, how much accurately the model can distinguish between the objects. Now F1 scores look for the true negatives. How distinguish our model can differentiate between the true negatives of the data. And specificity, because specificity also looks for the, you can say, loss and the negative value, how the system defines the negative value. Moving onwards, these are the results achieved by our model when we did the cross verification. We have recall about 97%, accuracy about 96%, precision about 95%, specificity about 95%, and F1 score about 96%. Moving onwards, we have hyperparameter tuning. This will be explained by my friend Milon.
Thank you, Amonsi. So now I'm going to discuss the hyperparameter tuning. So this is the very crucial step of our project. So here hyperparameter is a process which help us to optimize the model by choosing the base combination from the parameters of our machine learning model to improve the performance and accuracy of this model. And after using the hyperparameter, we get the full access before training and control how the model learns and how we can modify it after the training. So here we are using the in these parameters we are taking mainly the learning rate and dropout rate and also the denseness unit. So after that, why we are using for there are a lot of um, hyperparameters as hyperparameter tuning technique. So from them, we are using Opsuna. Due to Opsuna is a faster than other hyperparameter process like gate search and random search. And second is it is automated and scalable, which helps the model to automatically generate the base combination from the model. And it is also support the early stopping. Early stopping is a process which helps the model to stop the model echoes if the model echoes continuously dropping the accuracy. Then after using Opsina, we got the value which is test accuracy around 96.49 and test loss is 0.19%. After that, these are the results after using Opsina in our model. Then this part will be continued by my friend Omoji.
Thank you, Milan. Now we have came to the conclusion of our, you can say, project. So in conclusion, I would like to say that our model aims to reduce the time taken by the clinics to see if there is malaria parasite in bloods. It also reduces the human involvement in the process because through human involvement there may be sometimes mistakes made, and by that you can get the wrong idea about your result. And our our system also aims to fasten the process. It can generate the result in seconds. As to the time taken by the clinics, that will be around 30 minutes. In future also, we aim if we aim to continue in this path, then we will need to collect the data set of that region on which we want to study and establish the system, because region by region the DNA changes and also consumption changes. So that's why we will need the data set of that particular region. We will also need the help of fundings, and we'll also need to increase the accuracy and reliability in of the dataset, new dataset in that regions. And saying that, we would like to conclude our project presentation today. Thank you.
Uh, can you show the demo part?
Sir, the demo part is in different system when due to there was no means current here before, so that system doesn't have charge now. That is why we cannot show it now. We'll show it tomorrow, sir.
Yes, definitely you prepare with that. And questions may be asked like precisions, like you come to the slide, precisions, accuracy, recall, that slide. Yes, it's just wait. There you have recall, accuracy, precision, specificity, F1. So F1 score is okay. But if accuracy is there, then why again we need to take care of recall and precision values? So one line answer will be what exactly? Have you got my question?
Yes, sir. Sir, because accuracy only gives that how it is predicting, but overall how it will predict, how it will differentiate if some new data comes, we cannot know only through the matrix of accuracy. So we need the other matrices to overall understand the system, and that we can understand that if this system is reliable or not.
Okay. So if I say true positive divided by true positive plus false positive, this formula, what is that formula for? True positive divided by true positive plus false positive. Okay, we should know the formula very well. Similarly, true positive divided by true positive plus false negative. That formula.
Currently, we are confused. We will
Yes,
see it.
yes. That's why I asked actually what happened. Not only you, actually, every people may got confused with that. And one is we use for precision, and one other is we use for recall. Where we focus only the positive, truly positive results. In one case, we are just considering what? True positive plus false positive also. But if you take care of false positive, that is nothing but actually negative, true negative. False positive means what? That is actually negative, right? Similarly, if I say true negative, that is actually what? False positive, right? So these formulas we should not confuse with. Okay. And again, come to the hyperparameter tuning part, sorry. Okay, next slide, please. Next slide. Yeah, 0.1977 is the test loss and accuracy is 96.49. So what do we exactly understand by test loss?
The test loss means, sir, generally when we you can say, run the test, then there are some losses. Means when we go for epoch to epoch, if we see, then there are some generally losses
What losses?
that we do not, sir, you can say data losses.
Why this happen?
Sir, because no model there is exactly that will give you 100% that you give the data to the model. It will never give you the 100% result of it, because there will be losses when you do it. Because when we do the neural network, it goes from the dimension to dimension to dimension. So if exactly there are more dimension, then more losses will be happening, and that will be lost in the nodes of the dimensions.
There is a term for that. What is that term? This arises, as you have said, because of the dimensions, right? More features increase, means features are increasing, dimensions are increasing. That's why this loss occurred, right? This is known as what? This is known as curse of dimension. Remember, huh? This is known as curse of dimensions. And overfitting, I hope you have heard the term.
Yes, sir, overfitting.
Is it somehow related to that?
Sir, yes, overfitting also you can say that it is related. But for overfitting, there are many cases to be seen. It's not only related to that train loss or test accuracy, because if the data set is biased, if suppose there is about 80% of the data is positive and the rest are negative, then your model will be always biased towards that because of overfitting. Because when you do the training, the there if the data set is already 80% positive, if you split it again, then also the majority part that the model will learn is positive, and he will not know how to handle the negative part. So when we talk about overfitting in this area, then there are way too many things to consider. And yes, it also, test accuracy and loss also plays a part, and dimensity also plays a part in it. But I think the biggest part first will be the data set, then also the weight, and the, you can say, optimizer that you are using and how you are using in the model and a code also. So these are the things I believe will impact when we do the overfitting, if we talk about overfitting.
Okay, so
And sir, I want to add that our model, as you can see, I have also discussed about the data set. Our data set have 50-50% both infected and uninfected data. So it is really very much hard or kind of impossible to get overfitting until and unless we do some arbitrary hyperparameter tuning. But we have used that, so we have used Optuna to get the best result, and it will also take care of the overfitting.
So according to you, Optuna is, means best one in this case, right?
Yes, sir. Yes, sir.
Means how could you justify that? Means any literature you have found, or you have any other reason?
Sir, while doing in our internship, we have done some research about hyperparameter tuning. So there only we have gone through some literature and other thing that they have used different hyperparameter tuning techniques, but Optuna is one of the best, and it is lightweight and it is faster than the others.
That part actually I am talking about. If possible, means before this slide, include only one slide where you will mention others and their comparisons, that from the literature itself, you can mention that this is the citation. In this literature, we have found that Optuna is better in this case. So we have gone for Optuna, right? Because in this type of research work, we always have to have some evidences, right? Why you have selected that, right? So this part you can include before this slide. Okay?
Okay, sir.
Sir? Okay. So of all the means objectives are accomplished, right?
Yes, sir.
Very good. And if I ask you that any possibility of improvement, then have you thought about that? How can we do that? Means how can
Yes, sir. If we want to do this project and we really want to help the masses, then we have to see the reason where we want to implement this. Suppose we want this project to be applicable in Northeast, then we have to have the data set of the blood samples of the infected as well as the uninfected persons living in Northeast. Because if we move from Northeast to North India or Central India or South India, like that, if we go, then the composition and the way of the DNA is changes. Because even though India is sounds a country, but region by region, the population changes, its DNA changes, its structure changes. So if we want to get the accurate result and the most possible results, then we have to get the data set.
You are
Next,
talking
we
about
have to
real-time
see
data set, real data set of that region means.
Yes, sir. And next, we have to see that these results that we have gathered and gives the gives result in real time and also in short amount of time, because many people will be using this, so we want it to give as fast as possible. And we have to also check for the fail safes and other things, because we don't want others to hamper in our result. Many people are there who will be trying to modify our models and all other things, so we have to look for them also if we want to implement in real cases.
Any
And also the
improvement you think that you can do? Algorithmic improvement I'm talking about, like CNN. So any other algorithm that can be used here?
Sir, for image processing or computer vision, CNN is still now the latest and one of the best algorithms. So till now, we don't think there is some scope of improvement as per the algorithmic part. But in future, if some other comes, because there are continuous innovation going on, so if something better than CNN comes in future, we will try to means
implement.
make it with using it.
Okay, good. So I think that only thing we can look after is the pre-processing part, and also the that this hyperparameter tuning part. There is a possibility that where we can walk, because CNN is of course is now is considered as a training one, so no other scope of improvement there. Oh yes, we can go for means that again involves like a in-depth research on CNN, but that is okay. But pre-processing part you can take care of, and also the hyperparameter tuning where some works can be done. But till now, I can say that this work is very good. I'm satisfied with your group. And have you submitted any research paper or any research paper published?
So we have submitted this research paper in various journals, but Tinlight is not published. But we have also presented in the Bionist. There we have got the chance of incubation, and we have also we have also had a get together with them, and we have came to know various insight about our project and what are the difficulties that we may face, and why someone match we are doing this project for 1 year, so why we haven't used the real-time databases. So we have also discussed with it, but there are very much ethical issues, and we need some government schemes or government funding for doing that. So we have also discussed this with them.
Yeah.
And while doing that, we also came to know about the problems when we talk about gathering data set. Is that to get the parasite in the blood cells, the patients need to be in the high state, means in the peak form of their, you can say, when they are peak fever, when they have the peak fever, we have to be there, present there. Then only we have to get the blood sample. Then we have to take the blood sample, and directly we have to take the picture and then feed it to the system, because it only stays there for a few seconds. And if it is not in the peak state, then we'll never find the parasite in the blood. So like that, they told us about many things, the issues related to our, you can say, samples, ethical, moral, political issues also, like that laws. And like that only we have to see about it if we want to go forward with this project in the future.
Okay. So thank you. Very good presentation. And I hope that tomorrow you will be ready with that other system also, if possible, right?
Yes, sir.
And okay, that's all from my side. All the best.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir.